right, so we're going to go through rational functions. It's the second part, getting the last little bit of stuff. So things that we did yesterday. First thing that we found was the domain. Set the denominator of the original fraction equal to 0, solve it, and you want to try to solve it using what method? Factoring, because that's going to help you for the second step, which was simplifying the fraction, and then that simplifying is going to be related to one of the things that we're going to add in today. So simplifying is the second step. After we've done that, we look at the asymptotes. And with those asymptotes, we had vertical asymptotes, which every one of them will have, unless everything in the denominator cancels out. And then horizontal asymptotes, they occur when the degree of the numerator is less than the degree of the denominator. It's at y equals 0. If the degrees are the same, it's the ratio of the leading coefficients, y equals a over b, or whatever the numbers are there. Or oblique asymptotes, with the degree of the numerator being one more than the degree of the denominator, then you have an oblique asymptote. Do you ever have oblique and horizontals together? Never. Never. Okay. Is it possible to not have obliques and not have horizontals? Yes. When would that happen? Say it again, Derek. If the degree of the numerator is 1 greater, that's an oblique. Yeah. Is that not? No. Okay. Maybe when it's more than just 1. So like if the numerator had a degree 2 more than the denominator, like x to the 4th over an x squared, that would be a case where you don't have either of those. That's right. Good job. So when we don't have horizontals or obliques, it doesn't fit one of the rules for the degrees of the numerator compared to the denominator. That's when that happens. That doesn't happen a whole lot in what we're doing. They kind of set it up where you have to do some of that stuff the whole time through. But that does occur with rational functions. So those asymptotes, did all those yesterday. We'll do them again today as we're working here. So that'll get us there. The next thing that we're going to look at are intercepts. What kind of intercepts do we have? X and Y intercepts. Both of those are what we're going to look for that rational function. And then the last thing are holes and crossings. Remember that we can cross horizontals and obliques, but we won't cross vertical asymptotes out of that. So the holes are directly related to the simplifying step, and we'll see that as we go through here. Not every one of them is going to have holes. If something cancels out, that's when you know that there's a hole in the graph. And we're going to talk about how to find that, where that hole exists, and look at that as far as the graph goes. Okay. All right, so let's start with a nice example here. F of x squared minus 4 over x squared plus 5x minus 14. So we're going to do those 5 things for this particular rational function. All 5 of those things there at the top. So first thing we're going to find is the domain. So we do that by doing what? All right, so x squared plus 5x minus 14 equals 0. We'll try to factor that. And what are the factors for that one? 7 and negative 2, so x plus 7, x minus 2. And that tells us that x can't be negative 7, x can't be positive 2. So domain, all x's as long as x does not equal negative 7 or 2. There's our domain. Easy enough. I've already got the factored form of the denominator now. What's the numerator factor as? Yeah, it's a difference of squares, so really easy factor in there. What cancels? The x minus 2's. So our simplified form has x plus 2 over x plus 7. Okay, so we've simplified that fraction. Now, because of that cancellation, that tells me that there's going to be a hole in the graph. Okay, there's going to be a hole in the graph because of that cancellation. Now, vertical asymptotes would be the next thing that we did yesterday. Because of the cancellation, the only vertical asymptote we have here is what? -7. So x equals -7. That's the only one we have because that's the only thing left in the denominator of the simplified version. Remember, vertical asymptotes come from the simplified version of the fraction. Domain comes from the original. Right. Now, that relationship between the domain and the vertical asymptotes, because we had that place canceling out, the two that canceled out with that factor x minus 2, it canceled out. It's still not part of the domain, so that's why there's a hole at that spot. Okay, so we're gonna find that hole in just a minute. Let's get the oblique or horizontal asymptote. Which one exists, or do either of them exist for this problem? Horizontal asymptote, we're at y equals 1 because the degrees of our problem are the same. You look at the original, it's x squared over x squared. That's the same, so the 1 over 1, the ratio there. If we look at the simplified version, we should still get the same answer as far as the horizontal or oblique asymptote. So because horizontal asymptote is y equals 1, we know the oblique asymptote does not exist. There's not one. Okay. All right, so this is all that we did yesterday. That's what we spent time doing yesterday. Today, we're adding in the holes, the intercepts, and all that stuff. So let's go ahead and find the hole. The hole in the graph exists if you have a factor that cancels out. That's when a hole exists. Not every one of them is going to have an empty spot in the graph. This one does because we had a factor that canceled out. That factor that canceled out was x minus 2. So there is a hole at 2. Notice it's the same number that was missing in our, one of the restrictions from the domain. It's got to be in there too, okay? So we know there's a hole at 2, but what's the y value where that hole is? Where's that empty circle on the graph? We need to find the ordered pair that goes with that. So we're going to take this and plug it into our function and find f of 2. Now I'm going to use the simplified version because it's shorter, right? So it'd be 4 over 9, right? Going to look at the simplified version, x plus 2 over x plus 7. So the hole is at the ordered pair 2, 4 over 9. If we were to graph this by hand, we would put an empty circle in that spot. That's what represents a hole in the graph. That's what we're talking about there. We'll look at the graph in just a minute after we find the intercepts and get that going. Okay. All right. So let's find the intercepts out of that. So we got a hole at 2, 4 over 9. Let's find the intercepts. Okay. So y'all said we had x-intercepts and we have y-intercepts. How do you find an x-intercept? Put a 0 in for what? For y. So that's saying take the function and set it equal to 0 and solve it. So solving rational equations, if we think about this as a proportion, makes it easier to do. You just cross multiply. 0 times x plus 7 cancels out. We get x plus 2 equals 0. X equals -2. We have an x-intercept at -2, 0. And that's the only one we have. -2, 0. If your rational function is only one fraction, which most of them are, the numerator set equal to 0 is going to give you your x-intercepts. The denominator is always going to cancel out. Now that. So the shortcut is just set the numerator equal to 0. That's the shortcut. Mathematically, this is really what you're doing. You're setting the whole thing equal to 0, but we know that the denominator is going to go away. The numerator is the only thing we're solving there. Okay, so that can save you a little bit of time and writing as far as that goes. Now, how do you find a y-intercept? Set the x is equal to 0. So we plug in 0 for x. 2/7. So the y-intercept is at 0, 2/7. So we're getting some nice fraction answers there, and that's okay. That happens. Everything is perfect. All right. Now, we also want to find out if that crosses the asymptote, the horizontal or oblique. We had what kind of asymptote for this one? Horizontal at y equals 1. Okay. So what we're going to do is take that equation and set the rational function equal to that equation. So if you've got a horizontal asymptote, it's y equals 1. So we're going to take the actual x plus 2 over x plus 7 and set it equal to 1 and see if we can get an answer. If we get an answer, then it crosses it, and we can get the ordered pair at where it crosses it at. If we don't get an answer, all the variables cancel out, then it doesn't cross it. And we just say doesn't cross. Okay?
Pardon the interruption, please. At this time, all 8th graders need to report to the cafeteria. All 8th graders to the cafeteria.
All right. So,
teachers, if you have not posted attendance, please post attendance at this time. We've got several that haven't posted.
Okay. All right. Let's find out if it crosses. So we're going to take the simplified function. You could take the original if you wanted to. The simplified one's smaller, so that's one I'm going to use. That makes sense, right? To use the easier one. So we're taking x plus 2 over x plus 7 and setting it equal to 1 because our equation was y equals 1. F of x is the same thing as y. So we're taking that what f of x is equal to, that's y is equal to the actual function. So y equals 1, the function should equal 1. We're going to solve that. This one, it's just solving like proportions. Think about writing 1 as a fraction, 1 over 1, and cross multiply. That's what we want to do here. That's the short, easy way to do that. So that's going to give us x plus 2 is equal to x plus 7. This is just multiplying both of those by 1. And then solve it for x. Try to get x by itself. What happens when I try to start solving this? Yeah, when I subtract x minus x, they cancel out on both sides, and we get 2 is equal to 7. Does 2 ever equal 7? No. So this means there's no solution to that. If there's no solution to that equation when you solve it, that means it does not cross the asymptote. So this tells us that it does not cross. That's what that tells us. Because there's no solution. If we got a solution, we would know, hey, it crosses at x is this number, y is whatever the 1, if that was the case there. Okay, so we're solving that to decide what's going on. Let's look at the graph of this function. Let's see what it looks like and try to find some of those pieces. Okay, I'm just going to go to the simplified version, x plus 2 divided by x plus 7, because it's quicker to type in. and I'm zoomed out. I'm gonna hit zoom 6, so then I'm gonna back. And we see a vertical asymptote looks like, you know, should be where? -7, right? 1, 2, 3, 4, 5, 6, 7 right there. It makes sense. We see it shaping the graph there. With horizontal asymptote should be where? Y=1. We see that this line is flattening out here, and there's Y=1. What's going on there? We know that there should be a hole in the graph at x equals what? At x equals +2, right? So if I hit trace and 2, trace, whoops, wrong way. Trace 2. It's a little bit off of the graph there, isn't it? All right. So we're seeing the graph shaped again by the asymptotes. We're finding those pieces that are happening there. If we graph Y=1, that horizontal asymptote, we zoom out, we're going to see that blue line getting closer and closer to the red line, but it's never going to jump across it. Because we proved that algebraically by solving that equation, that it's never going to cross it. It's going to get so close to it that you couldn't slide a piece of paper between them, but it never crosses it. Okay, and as you get into calculus, the thing called limits that happens, and you can see that this leg of this graph it approaches 1, but it never gets there. Is what we call that. So finding these things. Let's look at another one, see what happens with it. Experience is the key here. F of x is equal to 6x squared plus 9x over 3x minus 2. Bless you. So a fairly simple one, but it has some key characteristics here that we're looking for. First thing that we should do, find the domain. (3x minus 2 equals 0). That doesn't factor at all. We just solve it and get x equals 2/3. So we know all x is as long as x does not equal 2/3. Minus 2. Does the numerator factor? Yeah, 3x is the common factor. That'd leave you 2x plus 3. Does it simplify any? They look similar, but they're not the same, right? So they can't cancel. So we don't have any cancellations here. Because we don't have any cancellations, what do we know the graph doesn't have? A hole. That's right. Because it has to have a cancellation of a factor to have a hole in the graph. Okay? Because it doesn't do that, we know that's one less step I have to do. Okay? Now, what else do I know about this graph as far as any of the other parts, the 5 things that we were looking at? It's an oblique. Why do you know it's an oblique? Top is 1 more than the bottom. We'll look at the original. We see that it's x squared over x, so we know that this is an oblique asymptote. So that means the horizontal asymptote, it's not going to exist. And so we're going to find those things. So we got the domain already. The simplified thing, it doesn't even simplify because nothing cancels out. So vertical asymptotes, because nothing canceled, our vertical asymptote matches our domain. So it's x equals 2/3. And we know that the horizontal asymptote doesn't exist. It's none. That's what but the oblique does. So we need to find the equation of the oblique asymptote. How do I do that? Do long division. Technically, I could do synthetic with this one, but I'd be doing synthetic with a fraction, which is, I think long division makes it just as doable. So I'm going to take 3x minus 2 and divide it into 6x squared plus 9x. What times 3x would give me 6x squared? 2x. And then minus 4x. Subtract. That'd be negative. That'd be positive 13x there. Technically, it's plus 0. What times 3x gives me 13? It's a fraction. Ish, but what's the fraction that gets there? That's right. 13 over 3 is the fraction that gets us there. And then 13 over 3. Does it matter what the remainder is here? When we talked about that yesterday. Once you get an mx plus b up top there, you're done. You don't have to worry about what the remainder is. You're not trying to solve this by long division. You're just trying to get the y equals mx plus b version of the oblique asymptote here. So we don't have to finish this out if we don't want to. I mean, it's minus 26 over 3. And you subtract, and you get something there. It doesn't matter what lands there. Who cares what the remainder is? We know it's not 0, right? So our oblique asymptote is y equals 2x plus 13 over 3. Okay. Now, we take that, we look at that and say, okay, well, the next thing that I want to find are my intercepts. So I've got in the domain, I've got my vertical asymptotes, horizontal and oblique asymptotes. Then let's find the intercepts. So to find the x-intercepts, what do? Plug in 0 for y, so we're setting 6x squared plus 9x. Technically, we're setting over 3x minus 2 equal to 0, but we know what's going to happen to the denominator. It'll cancel out. So here's where that factoring of the numerator comes back to help us, because we already know that that's 3x and then 2x plus 3. We get 3x equals 0 and 2x plus 3 equals 0. So x equals 0 and x equals negative 3 over 2. So we have two x-intercepts, one at the origin and one at negative 3 over 2, 0. Two x-intercepts for this particular graph. And then we need to find the y-intercepts. And how do we find y-intercepts? Yeah, plug in 0 for x. A little easier thing to do. 6 times 0 squared plus 9 times 0 over 3 times 0 minus 2. So it'd be 0 over anything. It doesn't matter. It's 0. So that y-intercept happens to be the same as the x-intercept. That is going to happen when that x-intercept or y-intercept is the origin. That's the only place that the x and y-intercepts are the same. So technically, if you were to look up the answers to this, it wouldn't list them as x-intercepts and y-intercepts. It would just list the intercepts. And it would only list 0, 0 one time. But we know process-wise, this is what you would go through out of that. So technically, we didn't have to do that because it was the origin. So anytime the intercepts are the origin, you don't have to find the other one that goes with it. That's why I always find x-intercepts first, because you can have more than one x-intercept. You're not going to have more than one y-intercept. Okay. We know that there are no holes in this graph, so we don't have to do that. But we need to find out, does this graph cross the asymptote? A little tougher problem there. So does it cross the asymptote? So we're taking the function 6x squared plus 9x over 3x minus 2 and setting it equal to the equation that we found for either our horizontal or oblique asymptote. We didn't have a horizontal, we had an oblique for this one. So we set that equal to the 2x plus 13 over 3. And we solve that. Okay. What do we start with here?
Just find the denominator times the right side.
Very good. Absolutely. If we multiply the denominator times the both sides, technically, you know it's going to cancel out on that side, and we're going to multiply out this side. So there's 6x squared plus 9x is equal to, and I'll multiply that out, 6x squared minus 4x plus 13x minus 26 over 3. Multiply that out, simplify, we get 6x squared plus 9x minus 26 over 3. What do we know is happening here? Yeah, this cancels, and we end up with, if everything cancels on the left side, what's over there? 0. Does 0 ever equal negative 26 over 3? No, I hope not to. Okay, things don't work well if that ever happens. Okay, so this tells us that there's no solution, and because there's no solution, does it cross the asymptote? No. So not incredibly hard stuff here. It is a process, and it does take some time. These problems are not short in most cases. It's just, you know, it just takes some time. So the asymptotes, all those rules, things we went over yesterday about you will have vertical asymptotes unless the entire denominator cancels out. That doesn't happen very much, but it can happen. Horizontals and obliques based on the degrees, and then you could have some that don't have either of those. And if that's the case, it saves you the trouble of finding whether or not it crosses the asymptote. You don't have to find that. Okay. So, but remember, you're not going to cross the vertical asymptotes. You can only cross obliques or horizontals. Okay. It doesn't get much deeper than that. I mean, it really is just straightforward what we've done the last 2 days. So page 373 is the first section. And then page 382 is the second section. You've got 45 minutes or so left in here today. You'll have a work day. Whatever the next day we're at school, if we're out Monday, they were given some snow and ice on Sunday night, but I think they kind of taken that out. It's going to turn cold, but I don't think it's going to be precipitation and things. But if for some reason we are out on Monday, the next day we're here to work day. Okay, so I would definitely, because these problems take a while, I would go ahead and start working some of them today, and that way you get to the ones that you might have questions about next week. So.